All right, we're going to tackle this section 40 through 45 all on one page. Let's see if we can do it. All right, so with question number 40, what we want to do is take the square root. So I will be looking for a perfect square factor embedded in 125, and that would be 25. 25 times 5 is 125. And then I'm just going to take the square root of 25, which is 5, and leave the 5 underneath. So there's that one simplified. This number here tells me I have to have 3 of a kind. And I know you guys don't like this, but can't help it. But you just have to have 3 of a kind before you can take one out because they cancel. I can see that this x already cancels with this radical. The cube and the cube root cancel each other out, so I definitely know I have an x on the outside. Let's just pull that out just to start with. And let's work on that 16. 16 actually has a perfect cube of 8 in it. And so that will give me 8 times 2 times the y squared. Now that y squared, folks, is going to have to stay put because we're not going to make it a 3. So, but this cube root of 8, the cube root of 8 is 2, so I can actually take the 8 out. And what I'm left with is just a 2, this 2 right here, and the y squared. There's your answer. 42. All right, this is a simple one. Subtracting. In order to combine, it must be the same kind. This tells me how many, -2. This tells me what kind, -8. Excuse me, square root of 8. This tells me how many, -3. This tells me what kind, square root of 8. We're in luck. They're simplified. So when I take a -2 and a -3, that's going to give me -5 square root of 8. Now, that's not quite simplified because the square root of 8 has a perfect square factor embedded in it, and that would be 4. Remember, 4 times 2 is 8. I've done nothing but split this up into factors. And now, since this is a perfect square factor, I can make it a 2. Well, it's greeted by the -5, so this becomes a -10 square root of 2. There's your answer. Number 43, not as easy because they're not the same kind. We have a cube root 4, cube root 32. However, what we must do is inspect it and see if we can create equal radicals. And I can do that by understanding what cube roots are. Again, I know cube root of 8 is 2, and 8 times 4 is 32. So, keep going. That's that first term. Cube root of 8 is 2. And that 4 has to stay put. Now I have equal radicals. Cube root 4, cube root 4. I have 1 here and 2 here. That gives me 3. So your answer is 3 times the cube root of 4. Done. Alright, so here we have multiplication. Different parents. Just do it. Don't have to be the same kind. Just multiply. So I have 5 times 2, which is going to give me 10. And 8 times 6, which is going to give me 48. And now again, I'm going to look for a perfect square factor embedded in 48. And I could have done this back here if I wanted to. I could have simplified the square root of 8 first. Order doesn't matter. I know that 16 times 3 is 48. The square root of 16 is 4. It's greeted by the 10. 4 times 10 is 40. This square root of 3 tagged onto it. Alright, 45. Suggestion. Always simplify on the front end. Make it simpler. Strike out those 3's. What is the square root of 4? I bet you didn't notice that. It's equal to 2. You don't have to rationalize the denominator on this one because of that perfect square. There's your answer, simplified. Folks, that concludes this video. This was short. We'll see you in the next one.